Real quick review. Yesterday we went over 3 ways that I could prove triangles similar. 5 ways to prove congruent, 3 ways to prove similar, and they would be
similar.
all right. As we go to the proofs today, only one of them is going to work. Here's why. What do you need to know about the sides and side angle side and side side side? Tell me they're similar. They have to be in the same ratio. And to know that, you need to know the side lengths. Everyone agree? How many times have we done a statements reasons proof where I've given you side lengths on the diagram? None. Okay? None. All right, so there's no way in a statements reason proof, if you're proving triangles similar, I can do side angle side and side 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 without knowing the side lengths. So my point today is, this is it. When we prove triangles similar, it's going to be angle, angle all the way. That's all I'm asking for. Can you find 2 pairs of angles today? All right, that's all I'm going to ask for. All right, so I go very, very easy here on you in the first one. I give you lines are parallel, WR and VB, and I want to just basically know why are they similar. This is also a good midterm review too, because a lot of these statements and reasons we are going to show up again in a couple weeks. All right, start us off. Somebody find me a pair of angles here. Oh boy, first up today, yeah, 30, going right to the end. R is congruent to V. Everything been all right over there lately? I haven't seen you stuffing your face lately.
Yeah. I haven't had pizza lately.
Because you know I just roast you?
Yeah.
It's all good. Yep, I understand. Good decision. 21, why is R congruent to V? Forms the Z.
Oh, R to V. I thought you said R to V. Okay, that makes more sense. That's on alternate interior.
Okay, what's the reason?
Or parallel lines.
Okay, parallel lines imply alternate interior angles congruent. I'm going to go slow through this because these are, it's also midterm review as well. All right, there's one pair. Now, could I put W and B in the same one? Could I put W and B in the same statement? Yeah, they're also alternate interior. Or you could go the vertical angles. Please don't put angle S congruent to angle S reflexive. At this point in the year, that's just downright embarrassing. Okay, putting S congruent to S. Which way do you want to go? Yeah, I really don't feel like writing an extra step today. So W congruent to B. Same reason. And then we have both pairs of angles, right? So triangle WSR, similar to triangle BSV. And yeah, it's all we're writing is angle, angle. How many of you are about to get a half point off because you kept writing congruent? Anybody? Instead of the similar sign, get used to it. Come on, get used to it. Similar. And there is a part B. It's not part of the proof, but it's just a little algebra problem. If SB is 10, WS is 15, SV 20, find RS. So you just got to know what sides match up here. Okay, just got to know what sides match up. And you can use your similarity statement if you'd like. You can turn the triangle so the congruent angles match up. It's up to you. All right, but part B, here we go. I'll start with the 15 on the one triangle. What would the 15 match up with in the other triangle? WS, what's WS match up with? SB, which is 10. And then on the other side, I would have XN 20. It's at 300. 10x equals 300, x equals 30. Any issues? Can they get trickier? A little bit, I guess. All right, we still have 2 more days. We're going to extend these proofs the next 2 days. But for now, all you have to find is 2 pairs of congruent angles. Oh, little rectangle. Yep. Unit 6. Just make sure you know which triangles we're trying to prove similar. If you want to highlight them, go right ahead. If not, that's your call. BAD. With BEA. All right, anybody want to find an angle here first? A pair of congruent angles somewhere. Let's go 19. Everyone see they both share angle DBA, the reflexive angle. Nice job. One pair down. How about the fact that it's a rectangle and you have perpendicular lines going here? Next one. Got to do a little more work here, though. 12, next up. Well, let's start with AQ being perpendicular to BD. What do I have in this blue triangle here? Where? Name the angle that's a right angle in that triangle. AEB is a right angle. Everyone agree? And it's also a rectangle. So where else would I have a right angle that's important to us? You got it. Okay, now, this is 2 separate steps. I'm not going to say they're both right angles because they're both right angles for different reasons. Do we see that? All right, they're going to be both right angles for different reasons. So I'll start with angle AEB is a right angle. Why would angle AEB be a right angle? Oh, yeah, let's go for... Thanks. And why is angle DAB a right angle? You got it? Nine, why is DAB a right angle? Nice job. Still got to tell me what about them, though. They are congruent. All right, so take both those in steps 3 and 4, make them congruent. AEB, congruent to DAB. All right angles congruent. Remember back in the day, you were doing your 3-step proofs and you thought they were so tough? I still think they're tough. Yeah, I know. I can tell. And then triangle BAD, similar to triangle BEA. Angle. All good? Just check again. Did you put the similar sign and not the congruent sign at the end? We all good? I can't get any tougher there, guys, so I'm not going to spend more time doing more proofs. Instead, what I'm going to show you is a little shortcut. All right, yesterday and example 1, we set up this proportion here. I'm just going to show you a quick shortcut if you ever want to use it. Called the Side-Splitter Theorem. Side-Splitter. Here's what the Side-Splitter Theorem says in a nutshell. If you have a line that's parallel to another line in a triangle, so in our case, BD and AE are parallel. If I have that, they have to be parallel. You can't do this on any triangle. They have to be parallel. So one line is parallel to another in a triangle. Here is what happens. The two other sides get divided proportionally. Here's what I mean. If I have those two parallel lines, CA is being cut proportionally into CB over BA. What is, come on, don't start. CB and CA. Same thing on the other side. CE is getting cut proportionally with CD over CE. Only if the lines are parallel, though. Now, can you just totally disregard this and say, hey, if I was doing this yesterday on homework, I'd go CB over CA equals CD over CE. Yeah, that's fine. This may be a little quicker, though, for some of you, and a little easier to handle. But if the lines are parallel, it cuts the other two sides proportionally. All good? Ready to factor? Quadratic formula time? I say quadratic formula, but that's never going to be an option for me up here. All right, in this class. All right, I'm always going to, if we can factor, we're going to factor. All right, find dB. If AE is X, dB, AD is 1, dB is also X, and EC is X plus 2, and those are parallel. All right, so if I wanted to right now, which I'm going to, I can use what's called the side-splitter theorem. All right, which says, all right, somebody take a side in one of the triangles for me. In the small triangle, take a side. Okay, X over X plus 2 is equal to, what do you have on the other side if I use side splitter? 1 over X. What? Okay, if you wanted to do that, I'm using side splitter, which says this line divides these proportionally. So X over X plus 2 equals 1 over X. If you wanted to do it like we did all day yesterday and on last night's homework, yeah, you could say X over 2X plus 2 equals 1 over 1 plus X. If you want to do it that way, that's fine. Both ways will get you to the answer. I just think this is maybe a little easier and shorter to deal with for some of you. But yes, if you want to do one side over the corresponding side, that's fine. But you see what side splitter's saying, Meg? That if the lines are parallel, they divide the two sides proportionally. One side over the other segment equals this side over the other segment. It's up to you. You choose. I'm not going to grade you down either way. All right, cross multiplying, I get x squared, oh boy, equals x plus 2. Highest exponent showing right now? 2, which means probably what? Factor. Possible factor, if not quadratic formula. You guys know how I roll. I always like whatever's squared to be positive, which it is. So let's move over the x and the 2. Now it'll end up being x squared minus x minus 2. Now look, you want to do quadratic formula, go do it on your own. Fine, go. All right, on tonight's homework. Here, I don't think, I keep saying this, but in this class, it should be no problem. What's your C value up there? What's the C value? -2, and what's your B value? Okay, can you find two numbers that multiply to -2 and add to -1? There's only two numbers that multiply to 2 out there, right? How do you make them add to -1? -2 and +1. Okay. So we'll go here. X equals 2 and x equals, bless you, -1. We'll have an awkward staring contest until somebody wants to bring up a point right now. Vincent? Why in this? Because I haven't rejected a negative yet when we factored this unit. Why now? It's a side length, and I can't have a negative side length. All right? So Fellas, just like some of your dating life probably in high school going to happen, rejected. All right? Truth hurts. Truth hurts. So too. Questions, comments, any concerns there? That's it. No, we had another one, didn't we? Yeah, right below. I got to scroll down. Yeah, I just didn't put it in, huh? This one is? Oh, that's the last one? I did, huh? Why don't you calm down back there? All right. I just didn't copy number 1, huh? I didn't copy it into the notes. Okay. All right. What? 4/6 equals y/9. Whew, everyone all right? Okay, moving on. All right, find ED. DE is parallel to CB. AD is 6. DB is x minus 1. ED is x. CB is 6. Got it. All right, I did this one on purpose like this. Do not copy this down. X over 6 equals 6 over x minus 1. I did x over 6, 6 over x minus 1. It's not the side splitter. You can't use side splitter here. What's the name of the theorem again? What is it again? Yeah, I'm going to be that guy. One more time. Side splitter. Side, not the base splitter. If I take x and 6 here, move them here, yeah, then you can use it. All right, but this is not an application of the side splitter theorem. It's only if the sides of the triangles are divided proportionally. That's it, not the bases. Okay, not the parallel sides. So I cannot use this here. Well, how am I going to do it then? All right, well, what if this was last night on the homework? Somebody pick a side of the smaller triangle for me. Oh, you're going hardcore right away. 6. This side right here, AD, corresponds with what side in the large triangle? AB. Be careful. Watch your mouth here. How long is AB? I need a stud here. 20? I needed a stud anyway. 8. Nothing. X plus, everyone see where you got, Colin got x plus 5? You take the x plus the 6 minus the 1. Please don't do this. I see this every year and it drives me nuts because kids don't know how to handle it. They do this. They literally write 6 plus x minus 1 and they never simplify it. And they go to cross multiply and it's just panic mode. All right, because I got 3 there. I don't know what to do with that. Of course you don't because you didn't simplify it. All right, simplify it, please, before you end up cross multiplying. So x plus 5. And then what's the, let's see, I got x and the x matches up with the 6 in the bigger triangle. Guys, all right with that setup? And are you okay? I cannot use side splitter there. Can't use the shortcut here. All right, not when they give me the lengths of the parallel lines. Oh, here we go. A little factoring again, huh? X squared plus 5x equals 36. I'm going to turn it over to you guys. Your next move other than panic. 19. 8. Easy superstar. We're not even close to that point yet. See what I have up on the board? Show off. Subtract the 36. Thank you. Two numbers that do what? Multiply to negative 36, but add to 5. Yep. And what are those two numbers that multiply to negative 36 and add to positive 5? 5 plus 9 and negative 4. I can't, if you don't like this, get the quadratic formula out and do it that way. Store in A, B, and C and go after it. Okay, if you don't like this factoring, you can use quadratic formula. So x equals 4 and x equals -9. Unfortunately, though, I cannot have -9 as an answer. Whoa, whoa, quickly. Just go back. What was I solving for? Find ED, and we labeled EDX. Okay, good. Then I don't need to go back and plug anything in. All right. Your show now. Your show. Going to have some factoring.